Hello everyone, welcome to Management Information Systems. This is unit number 5. In unit number 5, we're going to be talking about the foundations of business intelligence, databases, and information management. So pretty much we're going to be talking of how to structure the data and how to look at it to make sure that we have some insights, how we generate knowledge. Because data by itself doesn't tell us anything. It doesn't tell us the story. It's just a foundation of the story that we're gonna build. When it comes to business, we have tons of data, but we have to make sense of it. First, we have to arrange it. We need to understand it. We need to go through it to really assess what is it trying to tell us. Whether there are some insights, whether there's any information that can lead to a better business, to transformations, to changes, or to improve our business processes. So that's what we're going to be looking at this unit. So firstly, let's look at some basic concepts, right? This is the file organization. We're just going to look at it very, very quickly, because we're going to look at, firstly, what is a database? It's a group of related files. So we have database. We have, for example, here the student database. So we have the courses separately. We have the personal files. We have the financial files. We have many things within that database, right? So each of those files will have different information. In this case, for example, when we're talking about the personal file, we're talking about your ID, your course, your dates, your grades, etc. Then within that file, we go one level lower. We look at your record, which is pretty much your record in one specific line. And then, of course, we look at specific fields, and then we're talking about bytes. Bytes will already go into the technical part of it, as in we have a binary code, which is 010101. These one are letters in ASCII mode, and ASCII is a programming language. Well, it's a mathematical programming language which all the computers are based on. Even your Windows, the video that you're looking at me now, it's based on zeros and ones. So anyways, we have there the bit. So we go into that. We're not going to go into the technical part of it, into the bytes and the bits. But yes, the field, the record, the file, the database, is important that we have clear what it's all about, right? Why is it clear that it's all about? Because we have a lot of problems with the files. Yeah, and that goes already with traditional files as in physical files, because we as companies, as people, we have treated computer files in the same way we have done with physical files. And it doesn't work in the same way, because this leads to many issues. For example, files are maintained by different departments. So different departments work in different ways. And that leads to having data redundancy, which is the same information is copied, but it doesn't match. We have data inconsistency because the way that I do the data in my department might be different from yours. The same thing as on program data dependence. We may have different softwares that are not integrated. We cannot exchange information, and that gives us less flexibility. The same thing in terms of security of the data, because it's not in one server, because it's not standardized. The chances of losing that data happens very often, and of course, like I said, we cannot share it and we don't have it available, right? So let's look at, for example, here an example of. We have already spoken about data silos. So data silos happens because we have different users in different departments. Look at here, we have, for example, accounting, finance, human resources, sales and marketing, and manufacturing. They all have different kinds of information, and they have different applications, right? Maybe for human resources, I could deal with a very simple Excel form, and that's what I need. Or if I go more complicated, maybe I have a human resources management specific software that deals already with my daily management. But that is not going to be compatible with the manufacturing, because the manufacturer maybe is looking at other areas in terms of changes, in terms of daily performance, etc. So it might be different, but in the end, we need to make sure we match them in some certain way. We're gonna speak a little bit about that. So imagine, as in, we have different four different persons from different countries, and they all speak different languages. So what we have to do is make sure that they speak all the same language so that they can understand. So pretty much that's what we're doing with date. Okay, so what we started to do is, like I said, imagine that we have four people talking different language. The same as in the company, we have different departments talking different languages, and we have to standardize. And that doesn't mean that we are going to all speak the same language, but we're going to have a common ground where we can all understand each other. That doesn't mean that, like I said, four people speaking different language, one Spanish, one English, one German, and one Dutch, for saying something. We're not going to make them all speak English. No. What we're going to do is maybe a sign language. Through a sign language, all of them can come into an agreement of things that they want to share, right? So the same thing with this. When we have a data management system, database management system, which is how we're going to manage that data in order to solve some of the issues that we were talking about earlier. For example, less redundancy, inconsistency, the programs may match better, and then we manage centrally all the data. That is the idea, and ultimately is what we call an ERP, right? So an ERP software, what this manages, put all the information together, creates a database, and then we are all talking about the same language, right? So here, for example, there's an example here of how this works. I have, for example, a database of employees, right? So in this case, I might be talking about benefits view and payroll view. One is more about finance, the other one is more about the healthcare, and so other things. So in this case, I have the human resources database. So now, because I set different fields of the information that I have, there might be some information that might be useful for finance. There might be some information that might be useful for manufacturing, like we were talking about in the earlier, no? Here, for example, in the sales and marketing, this all comes together because as I have many fields that show me the information of one employee, like I said, I can use accounting and finance, how am I going to make more effective the payment of the employees? How many employees I need, right? So I have number of employees, so I can manage them. Sales and marketing may go together with manufacturing. Because I'm manufacturing, or I need X amount number of things to produce in this quarter or in this year, then I may need more people. Maybe, for example, I give you one example that Christmas season is coming, so many companies like FedEx or like Walmart or like Target, they need more employees to fulfill that demand. So in this case, what they are looking at is, we have, because of the marketing of this season, we need to manufacture more. If we need to manufacture more, we need more human resources, and we need to either hire more human resources or pay them more. And then you start to understand how everything comes together, because if we have four different databases, they are not connected, and then we don't know how many more people we can hire, because that can affect our sales and marketing budget, it can affect our finance. But if we're all connected, we can forecast what will be the ideal of number of employees that we need to hire, or how much more we need to pay them in extra hours. So that will make a lot of sense. So that is precisely why we have a human resource. For example, this one is a human resource database with multiple views, multiple fields, right? Multiple fields that can be used for different purposes. So when we have these database management systems, when we have so much information together into a database, it's easier to look up for information. So in this case, for example, if I come from the department of marketing and I want to use this database in order for me to understand how much I can produce, then I can look at the number of employees, at the number of the shifts, and I can make a query related as in if I want to achieve this number of production, how many employees I need and how much it's going to cost me. So that gives me information, for example, for me as marketing. Then I can think how much or for how much I can offer the product. So if I know that if I know that producing such large amount of production or things, it's gonna cost me a higher 30% more, then I cannot sell that product below that threshold. So that means that I have to think of ways of how I'm gonna add value in some certain ways so that I can either sell the product more expensive or it looks better, so etc. So anyways, this is SQL language, the structured query language. Give us the it gives us it makes our life easier because we can look for the information that we need in a more structured way, in an easier way. So it produces reports that are easier to read as compared to having databases that are really, really unstructured. We have a very large amount of information that doesn't tell us a story. And that is what I was telling you much earlier. We have a story to tell. We have to understand what the company is telling us, what the data is telling us, but we have a sea of information. So, like I said, maybe in my mind, I know what I want, what information I want. I want to know how much to produce, how much I want to, how many employees I need. That is on my mind. But how to look for that information, then this SQL language is going to look up for me the information that I want and will try to make sense of it and maybe visualize it as well. So we need to understand when we are doing a database, we need to do a design of it. And it's a design in terms of physical design and the conceptual design, as in terms of we talked about that the previous week, which is in the physical one, what kind of infrastructure I need, and conceptual as in how is that information going to flow so that there are no silos. So the moment that there's data silos, that means already that conceptual design is not done properly. The moment that when I try to retrieve my information, it chokes, it goes lower. That means the physical design as in this infrastructure is not accurate. So in this case, we have to plan it well. We have to understand what kind of data we have and how we're gonna connect it. And that's what I'm gonna take mostly of this slide. I'm not gonna go more into that. Okay, so as I was saying just now, we have a tremendous amount of information, and the challenge of having so much information or big data is that it comes in tremendous amount of unstructured data, or semi-structured. Sometimes it may come in terms of images. For example, some retailers use video information to see the traffic, but I mean, how are you going to assess that information? What kind of artificial intelligence system you have that can measure movement or can measure buys or can measure traffic in some certain way? So that becomes very complicated. When it comes to images, when it comes to videos, when it comes to audio, that information is not easy to record, no? Especially when it comes from social media. But anyways, we have great volumes of data. And one of the biggest problems of big data is that business managers, they think they can analyze it and get very good insights. But the reality of big data is that we're looking at the needle in the haystack. Yes, there's a needle. If we find it, it's fantastic. But to find it, that requires a lot of business intelligence, which is what we're gonna talk about later, which is we need to look at many dimensions of the data. We need to understand where the data comes from, how it was generated, what we want to achieve with it. And that's the most important thing. If we don't know what we're going to achieve with it, then it's difficult. And here, another big issue is the communication, because we have the people that is expert on doing the analysis of the data itself That means they know how to manipulate and move all the data to their will. But on the other hand, we have the business managers, which is they don't understand how to manipulate the data, but they understand about business. So the people that is the data scientists and those that do the analytics, they understand what data they need to retrieve, but they don't know the application of it in the business environment. And the other way around, business managers, they know what to do with the data that they receive, but they don't know where or how to look for it in the data. And there's already a miscommunication there between the data analysts and the business manager. So that becomes an issue. Right? So in this case, like I said, we need to look at the business intelligence infrastructure. So going back to the initial meaning of the business intelligence is having data and generating knowledge so that we can generate actions. Like I said, data itself doesn't tell anything, but once it becomes knowledge, means we are using that data for something and then we carry it into actions, right? So in this case, when we have a centralized data, when we have a data warehouse, when we have all the data located, like I was saying, rather than having silos of information, we have different languages, different sections. No, we are going to standardize and it's going to become a master data that has all the information in one place. So that is when we have as a data warehouse. That is the biggest scope of it. We have a very, very large, tank with data, right? And then we go to data marts, which is the data marts are within that large information, which in that big folder of information, that tank of information, we have small tanks. But that doesn't mean they are disconnected. Of course not. As long as they are in a data warehouse, then we section it so that it's very structured and somehow has better flow within the data. So let's say that it's, for example, like my computer. My computer has a lot of files, but they're still in my computer and then I can access it. However, if my data is properly organized, let's say, for example, I have, like I said, and I have this, take, for example, your computer. You have so many files. They're all in the same place. That means that you have a data warehouse. That is your computer. The problem is it's not well structured, it's not well organized. So what do? So you create warehouses. So all those files that you have in your computer is an example of a data warehouse, which is better structured, better organized, so you can retrieve it in a more intelligent and a faster way. I'm sure sometimes you lack, because of your lack of organization, you try to look for a file in your computer and it takes you 5-10 minutes to find it. Especially if you don't remember the name, etc., and you don't know where it's stored and so on. So that happens also the same thing for companies. We need to have a large data, and then within it we need to structure it accurately so that we can retrieve it. And then of course we use a lot of software or key services that process this big data. Like I said, in this case, going to the example of your computer, which is very, very simple, but pretty much that's what we do on a larger scale in companies. You want to know how your computer is performing, what kind of data you need to eliminate. You need to know what kind of data is useful for you. So you run a program that reads all the data within your computer and makes an analysis of it, right? Of course, you put some information that what you look for. For example, I want to know which data is pulling more RAM memory, or some memory is pulling a lot of information and is not needed. So precisely, that is what these kind of systems do at a large scale. They look for information that you're interested in, which departments, for example, are working better, which areas are underperforming, and when you know all that, then you can look for it and you can mine that data through all these hardwares like Hadoop or so. All right. So, anyways, we understand that. We understand. Well, we're talking a little bit of here of more of the hardware. When it comes to business intelligence, we have to have the proper infrastructure because if we don't have the proper infrastructure for data, like I said, it can cause delays. In some of the cases, delays in retrieving of information is not a big deal, but there are some industries that they need to work very quickly, very hard, and if your hardware is not up to the standard, then it may take very long time, and then you can miss a lot of opportunities as a company, maybe through quarters that are lost in terms of profit or revenue, right? Again, we're doing an analysis of data every 2 or 3 months to see whether we're meeting the standards of performance, right? So, like I was saying, we have tools for consolidating, analyzing, and providing access to vast amount of data. Like I said, this one are multidimensional data analysis, or OLA, which is, like I was saying, all these softwares that we have, like Hadoop, SQL. I forgot the name of the other one. Apache. Yeah, I think it's Apache. Sometimes I forget the names of all the companies. So, anyways, we have those softwares that are gonna do the data mining, the text mining, the web mining, images, etc., etc. So that becomes very complex, right? So in here we need to understand that we're gonna extract information to know some things. Here, for example, the question is how many washers sold in the East in June compared with other regions. So we are gonna use text, data, web mining. Maybe we can look at the Facebook pages that we have, or the advertisings that we have online, our website that we have online, to see how many people has been accessing it. In the text mining, we can say that we're looking at what the people is saying throughout our networks, throughout our websites, etc. Data mining, our sales. So we're looking at information in many areas. So we have, in terms of the look at this one, and this is precisely why it becomes very good to integrate data, because we're talking about, for example, different regions. We're talking about the product itself is divided into maybe into the different parts of the product, and then we have the actual performance and the projected performance. It can be in terms of which products are selling better, right? How many washers sold. Well, this is about washers, but let's say here we have the washers, bolts, screws. So we just want to know when we're looking at this data, we're looking at just the washers, we're looking about the West, and we're looking at the actual performance. Okay, so if we were to want to look at all that, maybe we can look at the projected one. So in the end, I'm gonna use this block of information to get to know the information that I need. However, if I want to do comparison with other products, I also have the information. If I want to compare with different regions, I have the information. So that is why having a multidimensional data works. That means I have maybe this one, some information collected by the different departments of marketing of different regions. Maybe I have different information from manufacturing, from different production sites, and then I also have the information from finance. So you see here we have at least three dimensions collected from different things to try to project and get information, and then take decisions of if this let's say, for example, if these washers are not performing well compared to other sectors in regions, and so what do we have to do? So again, this knowledge, and then once we apply that knowledge, we generate that business intelligence. Okay, very good. So precisely that is data mining in a nutshell, right? We want to look into the different associations, the sequences, classification, clusters, and forecasting. So we look at how the data is connected. We look at how it flows, how it's classified, how it's grouped into certain groups. Okay, and then where it's gonna move forward. Okay, so in this case, for example, we can look at the associations. Okay, we can look at the sequence. Made a mistake. We can look at the sequence. Like I said, there's different clusters. There's 2 clusters of information, and data and information. We can forecast that in the future our sales are gonna go down. If they are gonna go down, then I have to find a way to make it go up. Okay, so that is data mining. So pretty much is making sense of the information and understand how it's classified, connected, and then what we can do with it. Okay, very good. I think that should be very clear. Even I understood it. Of course, I'm the professor. Very good. So, well, and this goes together, like I said, with data, text, web, images. So we have the same thing. It comes in unstructured data because, for example, we can look at this, and give me an example. For example, here we have different words, key elements in there, and then starts to say how many times cloud was mentioned, computing was mentioned, and we start to make some sense out of it. We start to run more queries, and then that starts to work very well. And the same thing with the web content. But the problem with videos, images is that it's not very well structured, and giving it a structure is very, very difficult because it has tons of information. Very good. So, well, anyways, we're talking here about databases, and then these databases are usually used for internal usage, but nowadays, what is working very well is that companies are connecting to their suppliers or to their retailers or to any other people related into other companies related into the supply chain to share that information. So in this case, when they have access to that information, they can forecast more accurately whether there's going to be a drop in sales and so less production, less work, etc. Okay, very good. So suddenly I had a cough attack, so I had to pause my video. So anyways, so now we're looking at establishing an information policy. So whenever we are thinking of having databases, sharing information, having access to it, we have to think of all the regulations that go involved with it. Who can access it? How can we access it? Who has access to it? Security, etc. Privacy, and all of this calls for us to have a very structured protocol of what to do with the data, and that is not easy. And actually, it happens that there's a lot of information lost or breached or broken data, if we want to put it in some way, because this is not managed properly. We need to understand that data is one of our biggest assets, and as such we need to manage it properly. Imagine that, for example, in an analogy of it is we have a building and that's an asset for the company, but if we don't take care of it, if we don't clean it, if we don't take care of it, if we don't have it structured, checked out every now and then the building could collapse, right? Maybe if there's a leak, let's say for example there's a humidity leak in the second floor that starts to permeate already to the concrete and then starts to fall down. And that is exactly the same thing with the asset of information. We have a lot of information. It's like a building, and we need to have it well structured. Who goes in, who goes out of that building. If there's any problems with, like I said, the leakage of water, the same thing with the leakage of information, how we're going to cover it, what kind of information we lost, etc. And then how we make sure that we maintain that asset. So it is the same thing. Okay, very good. So let's go just quickly to the last thing, which is the same thing as I was telling you. Data is a building, is an asset, and ensuring that the data has good quality is important, because this happens very often that across departments they have their own methods to enter the data. And we need to understand that also wrong data can lead to wrong insights, wrong knowledge. It could be that, for example, some of the numbers are not keyed in properly, or it can be that in some departments we measure it in dollars, and in the other one we measure them in the local currency, and there's an issue. So again, we need to make sure that the data has good quality, because if not, it can be misleading, and that is one of the worst things that can happen, because um, that can generate a lot of problems, functional problems, and legal issues as well. It was the case of PayPal. PayPal just well, we still don't know if they did it on purpose or not. But this year they have issues when presenting their numbers in terms of the performance of their sales, in their transactions, etc. They misreported some numbers. So we can say that it was on purpose, maybe, could be, maybe the data was not accurate, but we don't know what happened. But they already got into legal problems with the stockholders, because the stock went down because they underreported things that they had to report. So with this thing, we have to think whether if it was caused by the management because they wanted to hide some numbers, that's unethical. But if it happens because the data hasn't sufficient quality, then that's a bigger issue, because that is going to keep on happening again and again, and that's a big issue for them, for this company, right? Very good. So that's for it for this week. And if you have any questions, please let me know.